The second part of our video lesson on covalent bonding will pick up with the slide that we left off on having to do with the rules. A great reference page as you begin these structures. Another thing that we want to keep in mind is that most elements will obtain an octet. The word octet refers to the number 8, meaning that the central atom that we are looking at will have 8 electrons associated with it. Now, as we look at that, there will be some exceptions to this. There will be some elements that will always have less than 8 electrons. Those being on the left-hand side as you're looking at the green arrow, that include the elements hydrogen, beryllium, and boron. Because of the fact that their size of the atoms, the hydrogen, beryllium, and boron atoms are smaller in size and their number of valence electrons are smaller, their maximum number of electrons are going to be less than 8. On the flip side, highlighted by the blue arrow, you will see the elements of phosphorus, arsenic, and xenon, which represent a small grouping. They are not all of the elements that will go beyond an octet, but they're examples of how they can expand to become bigger in terms of size. This reference page is called our NASIS page. This is definitely going to be a slide that you're going to want to flip back and forth to as we go through and understand how to put these together. We're going to be calculating what's known as NaS, A minus S, and from there, we're going to put our structures together. N is the number of needed electrons, where as you look in black type font, you will see that there is a multiplier number times the number of each atom, and to that you add the multiplier number times the number of each atom for each structure. 8 is always our multiplier number for all atoms except for hydrogen, beryllium, and boron. To explain this so that you do not become confused, I'm going to stop with N at this point and go to a few examples to show you how to apply this, and then we'll come back to this reference page. So as we look at our first set of practice problems, my first example is the element silicon with fluorine, so SiF4. As I look at Si and the element F, they are not my exceptions. Instead, they're just regular numbers that we're going to utilize the multiplier of 8. So to calculate N, I'm going to take my multiplier of 8. I look at my silicon, and there's one silicon, so it's 8 times 1 to represent Si. To that, I'm going to add fluorine. Okay, now when I look at fluorine, it also has a multiplier number of 8, but this time there are 4 fluorines. So now I have to just do some very easy math. 8 times 4 is 32, plus 8 is equal to 40. And notice that I get an even number. I always want an even number. Okay, now there's other things that we have to calculate, but let's go over to NH3 and do the same thing. Nitrogen is a regular element. Okay, so there's my nitrogen, multiplier number of 8. Okay, now to that, I have my next element, which is hydrogen. Now, if we go back and we look at the rules, notice that the rule for hydrogen says that hydrogen's multiplier number is 2. So because of that, I'm going to use a multiplier number of 2 for my hydrogen, and then there are 3 of them. So 2 times 3 is 6, plus 8 is 14, another even number. Okay, let's go and do 2 more example problems and calculate the N's. Okay, my third example has CO2, carbon dioxide. Regular elements, multiplier numbers of 8. 8 times 1 for the carbon. Add to that 8 times 2 for the oxygen. 8 times 2 is 16, plus 8 is 24. And finally, my last example in this small sequence is HCN, hydrogen cyanide. As you're looking at this, I want you to point out that the hydrogen again, is a weird multiplier number. We're going to use a multiplier number of 2 for hydrogen because it doesn't reach that octet number, and there's 1 hydrogen. Then add to it carbon, multiplier number of 8. Add to that the nitrogen, multiplier number of 1. So we have 16 plus 2 or 18. So again, very consistent with getting even numbers with our math for each of these. All right, so as we go back to our reference guide, and you're looking at the A value that's highlighted in maroon, A stands for the number of electrons available to be shared. Now, in black print, you'll notice that it says you're taking this time the group number times the number of each atom and adding group number times the number of each atom. Now, when I say the group number, we're going to refer back to the periodic table. So we're going to go back several slides to where we were in the previous video. And when we say the group number, we're looking at the Roman numerals 1 through 8 group numbers for this. So as we go through and apply our math, going back to our silicon tetrafluoride example problem, for our A value group number, silicon happens to be located in group Roman numeral 4. So as we apply the Roman numeral 4, we're going to write it as a regular 4, and there's 1 silicon. Add to that fluorine. Fluorine is in Roman numeral 7, so regular number 7 when we're writing down the math. And again, there's 4 of them. 7 times 4 is 28, plus 4 is 32. Notice that I'm getting an even number again. Okay, let's move on and do NH3. Nitrogen's in group 5, hydrogen's in group 1, and there's 3 of them. We do our math, we end up with 8. Okay, carbon dioxide. Carbon is in group 4, and there's 1 carbon. Oxygen's in group 6, and there are 2 of them, so we have 12 plus 4 is 16, again an even number. And we move on to HCN. Hydrogen's in group 1, and there's 1 hydrogen. Carbon's in group 4, and nitrogen's in group 5. And notice once again, we're consistent with getting those even numbers. So as we go back to our reference page, the next thing that we're going to look at is our S value, which are the number of shared electrons. And this is a very easy calculation. The shared electrons is simply the N value subtracting the A value. So as we take our N value, so we're again at silicon tetrafluoride, our N value happens to be 40. Our A value in this case is 32. Okay, now we're going to subtract them, and when we subtract them, we get 8. Okay, now, shared electrons. At this point, your shared electrons are 8. Tell us that if we have 8 shared electrons, that means that that will give us a total of 4 bonds, because to make a bond, remember you need 2 electrons. Let's do the same thing over here for NH3. 14 for N minus A is 8. 14 minus 8 is 6. Okay, now as you're thinking about this, if you have 6 electrons, that means that you have 3 pairs of electrons. In other words, you can make 3 bonds. Okay, and hopefully that's starting to click. With carbon dioxide, 24 was our N. We're going to subtract our 16 for our A. 24 minus 16 is 8. And as you're thinking about that, hopefully you can make the jump that that means that we have 4 bonds. And finally, our last one, 18 for N minus 10 for our A. 8 electrons, again, translates into 4 bonds. Okay, so that is 8 electrons And finally, as we go back to our reference guide, A minus S in maroon at the bottom is going to tell us our number of lone electron pairs. So as we look at our practice problems, the A minus S value right here is simply your A value. So in this particular case, we have 32 for A. We're going to subtract our S value, which is 8. Notice it's the original value. 32 minus 8 is 24. In other words, it means that we have 24 lone electrons. Okay, and we'll go ahead and do the same thing for the next one. So A minus S, 8 for A, minus the 6 that we calculated for the S, equals 2 lone electrons. Carbon dioxide, 16 minus 8 gives us 8 lone electrons for that one. And our last one is 10 minus 8. And in this case, we have 2 lone electrons. And that helps us gain some confidence with figuring out our calculations. Now, we are, of course, ready to build our structures, but to stay consistent with this particular video lesson, let's go ahead and look at a couple of different options just for trying the math. And you will notice as I flipped, there are 2 more pages of math problems that I would encourage you to try on your own before we learn to build the structures. So I'd like you to pause my video and try the problems and then check your work with me as we come back to pick up the next video lesson.